Swayam Prabha. Digital India. Educated India.
So, I will go to the example. Yes? Yes. So your question is, if hospitals propose, is there a concept of H optimality? So that is what I want to talk about next. So let's look at this example once more. So when hospitals propose, they are getting the best people. So in this particular example, right? So in particular, what H1 is getting with the hospital proposing algorithm, all of them are better than all of the people that H1 is getting with the R proposing algorithm. So question is, can it happen that say H1 gets first and fourth choice in one stable matching and second and third choice in another matching N? So I did not say H1 but just H. Okay, is the question clear? So here we see that H1 is getting strictly better partners. I mean, all the partners that H1 is getting are better than all the partners that H1 is getting in the other matching. So the red ones are strictly better than all the green ones. Is this a coincidence or is this a requirement or is this a property? So in particular, this will not happen if some hospital H gets its first and fourth choice in one stable matching M and say second and third choice in another stable matching N. So if this happens, can we say that M is better for H or N is better for H? So in this example, clearly we see that the red matching is better for H1 and also for H2, and the green matching is worse, strictly worse for H1 and H2. But then is this always the case or can some such thing arise? Okay, so let's try executing that way. So I'll copy this example and then we will execute. So again here that should not happen because order of execution should not matter, but let's see. So here what happens if the proposal order is different? Even here, like maybe even here that can happen, right? H1 proposes R1 and gets accepted, and maybe later on H2 proposes. So instead of H1 making the second proposal, in which case again it will go to R3. Yeah, so and after this H1 may propose or even H3 may propose. In that case H3 will propose to R1 but R1 will not accept, but R2 is going to accept. But when H1 proposes again to R2, R2 will reject this one and accept H1's proposal. So again H1 will land up with R1 and R2. So in whichever order they propose, they will get whatever they are getting in any other order. So irrespective of the order, here H1 is getting R1 and R2 in this table matching, H2 is getting R3 and R4. So, is this clear? Um, yes, and also we have not proved that anything called H optimal exists because we don't know how to compare two matchings from the perspective of a hospital, right? So, for example, if H has this preference list R1, R2, R3, R4 and not H proposing or R proposing, but say some matching gives R1 and R4 to H and some other matching gives R2 and R3. So, are we in a position to say that H will like the red matching more or the green one more? So, it is not clear that there is something called H optimality. We can list out the stable partners of H, but it is not clear whether there is any matching which assigns the first CH many stable partners to H. Yeah, so that is what we want to prove that, but then it is not very straightforward to see, right? So we want to say that this does not happen. And this comes as quite a surprising fact because this is not obvious from the way stable matchings, from the structure of stable matchings. It is not immediate. Okay. So there is, if two stable matchings assign different sets of residents to some hospital, then either one matching assigns better than, completely better than the other set or vice versa. So this case is actually true for all stable matchings. So here it happens that all red partners are better than all green partners. This will always be the case when H gets different sets in two stable matchings. And that is what we want to prove in the remaining time that we have. So if sorry. So if M of H is not equal to N of H, where M and N are stable, then every resident in MH, actually we should only look at what is not common, because if a resident appears in both M of H and N of H, it is not really necessary to compare them, right? So if we look at the sets like this, where this is M of H and this is N of H, then it makes sense to compare only these parts. So we can leave out the common part and the comparison can go only between these two. Okay. So we want to say that every resident in NH is better for H than every resident in NH minus NH. Or vice versa. So this is not the case with the red and green markings here. So H cannot have this kind of stable partners. So here leave aside the black set while comparing because they are common between both the matchings, and compare the red area, I mean the people in the red area with the ones in the yellow one. Okay, so these are the sets that a hospital compares, and one is strictly better than the other, no matter which two stable matchings you consider. So any question about the statement here? Okay, so I will again draw this kind of figure, but for these particular ones. So R1, R3 in one and R2, R4 in the other. So does this satisfy this statement? No, right? Because everyone here is not better than everyone here, nor is it the other way around. So H cannot get such partners in any two stable matches. Yes, so now we will have to prove it. So let's try to prove this statement. So again, assume that Mn are any two stable matchings, and H gets this set of residents in M, and it gets this particular set of residents in N. There is no reason why there should be an intersection, but there is indeed an intersection. If the sets are the same, then H has no reason to compare. So there has to be something which is in one but not in the other. Now suppose there is a resident R here and a resident R prime here. And R and R prime have the property that R is the worst resident for H in M of H. And similarly, R prime is the worst for H in N of H. Okay, so we are just looking at these sets M of H and N of H. We are simply ignoring this common part. We don't want to include them in comparison because they appear in both. So whatever are the different residents in M and N that H gets, we are only comparing those sets. And the worst among them is R. So I should say M of H minus N of H and N of H minus M of H. So worst here is R, the worst here is R prime. Now for R it is clear, for R there is a clear way to compare its M partner versus its M partner. Right? So for R, H is the M partner and there will be some other H prime which will be the N partner. And R can clearly compare H and H prime. And since R is not here, clearly R must be getting some other partner in N. Otherwise it would have been in the common part. Okay. So first we want to say that if R prefers, so when I say that R gets a better partner in M, that is R prefers H over H prime, I can as well say that R prefers the matching M over the matching N. So the preference for partners in the two matchings can be just extended to preference for matchings. Right? So R likes the one matching over other because R gets a better partner in one compared to the other. So if R prefers M over N, Yeah, so now we are not in a position to say that H prefers N over M or what, but at least we will say that H prefers R prime over R. Okay. So this is again a small claim that we will prove. So again this is similar to the one-to-one case where we said that if a man prefers one stable matching, his partner woman prefers the other stable matching, because otherwise they form a blocking pair with respect to one of the two matchings. Okay, so is the statement of the claim clear? Now we are only comparing the worst resident here versus the worst resident here for H. And if R prefers the matching M, then H prefers R prime. So this is what we want to prove. Now before proving this, let's see how this claim is going to help us. Okay, because it is not clear why this claim is going to be anyway helpful. So let's first use this claim and then prove. Okay, so consider any resident X here and any resident Y here. So they may be X may be same as R or X may be different from R. Similarly, Y can be same as R prime, it can very well be different from R prime. So 10 minutes maybe? Okay. Yeah, so I am just thinking whether it is easier to prove the claim first or whether we should prove the main statement first. Say it again. Um, hmm. Yeah, so let me. Okay, so R prime is the worst here and R prefers H. Yeah, so H has to prefer R prime over R. Yeah. So let's just complete this argument. So R prefers H over H prime. Therefore, if H prefers R over R prime, then HR blocks N. Okay. So now we have said that if R prefers the matching M over the matching N, then H is going to prefer R prime over R. Now what can we say about comparison of H between X and Y? Okay, so the question that we want to address now is how does H compare X and Y? So x is any resident in M of h which is not present in N of h, and y is anything that is present in N of h but not in M of h. So what if h likes x more than y? So if you look at this edge xh, this edge is present in M, and yeah. So we said that exactly one of x and h should like M and the other one should like N. So in fact this claim we want to make a little stronger later for any, okay, I will not do anything right. Okay. We have not really used the worst one, yes. Yeah, so maybe I will just not add to the confusion by writing worst, but I will just say R is in MH minus NH and R prime is in NH minus MH. Okay. So yeah, I have given some intuition for this claim, but nevertheless. So now if we are comparing some x and how x and h like each other. So if x likes M, then h is going to like N better in terms of its worst match. Right? So if we look at y here, this is an N edge. Yeah, I think here we should have that they are the worst ones, because the worst one we are always in a position to throw out. So now if h likes y more than x, so in the matching M, actually h is in a position to throw away r and take y. So in M, h can discard r and take y. Sorry? No, x is anyway there. Yeah. So basically h is in a position to throw away one resident from M of h and instead take y if h likes y more than x. So if h prefers y over r, then in M h can discard r and take y. And same holds for x. So essentially here we are saying that assume that r prefers h over h prime and hence h prefers r over r prime over r. So yes, because h prefers even the worst resident here over the worst here, h also prefers y more than r. Yes. So how do we say this? So we said that if H likes the worst resident here more than the worst resident here, then this worst resident actually prefers the other matching. As in, if one endpoint of an H prefers one matching, the other endpoint is going to prefer other matching. Right? So here the H R and R prime H, this tells us that H prefers this. So we also say that in the HY edge, because H prefers the worst resident in N, Y should prefer so Y should prefer the M partner more than H. So I have not really exhibited the blocking pair. So maybe I'll clean up this proof when we come back after the coffee break. Shall I do that? Okay. Yeah, I think I tried to bypass some tedious calculation, but maybe I'll just do that. So we'll come back and we'll just do this afresh.